SN2, substitution nucleophilic bimolecular. Reaction not only depends on substrate like it did in SN1, but it also depends upon nucleophile. The rate law determining step is the formation of the transition state, which involves the back attack of the nucleophile, and in the frontal the CX bond weakens, right? So that is the transition complex, and anything that stabilizes the transition complex will stabilize the pace of the reaction. Why is it so that the 1 degree halide prefers to undergo SN2 than 3 degree halide, and why SN2 reactions slow down if steric factors are there? So let us know more about SN2. Over to the screen. Reaction mechanism. Here we have a halide. So this is on the plane, this is away from the observer, this is towards the observer, and we have OH attacking from the back. So this bond weakens. So this is known as transition state, and it is not a separate step, it only stays for 10⁻⁻⁶ seconds. So the life is very short, and finally it breaks to give us alcohol. Now if you can make out the stereochemistry of A and B have been reversed, right? So B is actually like a tilted umbrella to A. The characteristics of SN2 will be, here rate will depend upon both on the nucleophile, attacking nucleophile, as well as on the substrate. So the order for this reaction will be 2. Since the attack is from the back, so the stereochemistry says leads to inversion. So SN2 leads to inversion. It will depend upon nature of nucleophile also. So strong nucleophile will favor the reaction. If you see, there is no carbocation formed, only a transition state. We have only a transition state, and that also cannot be isolated. This transition state cannot be isolated. Anything that will stabilize the transition state will stabilize the SN2, right? So please mind it, there is no carbocation formed. If you look at the diagram, you will feel as if this carbon is having 5 bonds, but this carbon is not having 5 bonds. The nucleophile is donating the electron in antibonding orbital of carbon, right? So it is donating in antibonding orbital of carbon, right? And when CX will break, the electron shifts back to bonding to form a bond. Polar aprotic medium will support the reaction because there are no charges. So we can take acetone as the medium. Acetone has polarity but no proton. We can take dimethyl sulfooxide. SN2 is also exothermic like SN1. So therefore, low temperature, the rate will be higher. Nature of halide will govern the reaction. It will affect the reaction. In fact, this point is same for SN1. So if X is a better leaving group, better leaving group means like I minus is big, can easily break, then we have, so this is the tendency of leaving, so reaction will be faster. Steric factor also will affect. More the steric hindrance, rate will be slower. any electron withdrawing group, because it will pull electron from the system, so it will stabilize the transition state. देखो ट्रांजिशन स्टेट में चार्जेस होते हैं. इफ द इलेक्ट्रॉन्स आर पुल्ड, ठीक है, तो ऑलवेज आपकी जो ट्रांजिशन स्टेट होगी वो स्टेबल होगी. और ये जो फैक्टर होगा, ये जनरली ये फैक्टर डोमिनेट करेगा स्टेरिक हिंड्रेंस में. ऑल अबाउट SN2. So if you want, you can sum it up as SN2 will be faster in 1 degree, followed by 2 degree, followed by 3 degree, right? Because the attack of the nucleophile will be facilitated if this is 1 degree. If we have bulky groups, nucleophile will get repelled and there will always be a tendency to form carbocation. So I hope the explanation was good enough, and now you know the importance of the solvent, steric factor, and hope with a given halide you will be able to make out whether it will undergo SN1 or it will undergo SN2 easily.